Okay, sorry, I've just noticed that there's not a chapter 6, so I'm going to do this really quick. The one that was up there was only 7 minutes long or something, which definitely wasn't all the questions. And there's more difficult questions in chapter 6 than there are in, I think, most other chapters. So I'm going to go through this quite quick, but you can just pause it on each individual question. I won't be writing anything because it's already been written down. So finding the midpoint of line segments is useful for finding the diameter, finding the center of a circle if you've got the diameter, because the midpoint of the diameter is the center of a circle. So if you've got numbers, easy, halfway between x coordinates, halfway between y coordinates. You can do that by adding the x coordinates together and dividing by 2. Or it could sometimes just be obvious, like halfway between 4 and 6 is 5. If you've got algebra, definitely you're going to be adding them together and dividing by 2. But just a plus b, add 3a minus b is this one. You get 4a, then divide that by 2. Same thing for the y coordinates, and it's done in algebra then. For the next questions, it's asked the line segment AB has endpoints A and B, but you don't know what B is, but you know the midpoint. So I would think of this as being like a sequence. If we're going to the midpoint, where that's halfway. So if it takes 6 to get to the midpoint, that's another 6. And then if it's taking away 2, then you just take away another 2. So here A is going to be 10 and B is 1. So let's have a look at some of the other ones. I've gone through and to keep it shorter. So this question is giving you the diameter of a circle and you know the points on either side. So firstly, if you want to find the coordinates of the center, just halfway between these coordinates. So halfway between the x's, halfway between the y's. And to show something is on something else. So if there's a load of these questions that come up, especially in circles, it says show the center. So if you're just showing it, all you've got to do is show that the x coordinates of the center, so this is the center, x coordinate and y coordinate of the center, and that says 3 by the way. I was going to write 6 over 2, but I didn't do this one in pencil, so that's a 3. You just show that the left hand side equals the right hand side. So substitute in your y value 3 and your x value 3 over 2 into this equation and show that 3 equals 2 lots of 3 over 2. So all you got to do is show that, literally write in the numbers. For this one, it moves on to the equations of a circle. So this is what I was saying about needing to go between the center and the radius and the equation. So if you know the center and the radius, you just substitute them into the equation, which is x minus the x coordinate of the center plus y minus the y coordinate of the center equals the radius squared. I forgot to say squares there, but you can see it. If you're doing that with algebra, it's just the same thing. Okay, that's the x coordinate of the center, the y coordinate of the center, and then the radius squared. You can need to be able to do that the other way around as well. So if you've got the equation, you should be able to go back to the center by looking at what's in the bracket. You want the opposite. So if it says plus 5, then the coordinate is minus 5. Same thing for the y, so opposites. And then the radius is the square root of that. So if it says 9 squared, nice and easy, that's 9. This one, question E, same kind of idea. Opposite sign for the center. And then the radius is just the square root of 27. I would probably leave that as root 27 unless it asks me to simplify it. Because I think just root 27 is easier to deal with, because most of the time, or a lot of the time with these, you're doing like Pythagoras or something, you're going to square it. So you might as well leave it as 27 because it's easier to square root 27. It's just 27. Right, next questions. And more questions that say show that. So to do these questions, all you've got to do is substitute these points, x and y, in for x and y and show that it's equal. So if you substitute 4 in for where x is and 8 in where y is, then you get 2 squared plus 3 squared, which is 4 plus 9, which equals 13. Left hand side equals right hand side. Okay, do the same with all of them and you'll get the same thing, whether it's algebra, surd or whatever. Substitute in the x, substitute in the y, use your calculator and show that they're equal. This is the last of the, I think, basic questions. There's a point on a circle if you, with a centre of 8, 1. So if you've got the centre, then you know x minus x coordinate squared plus y minus y coordinate squared equals r squared. Substitute in the point that we know lies on the centre, or sorry, lies on the circle. So put in the x coordinate as 4 and the y coordinate as -2, and then the radius is just the solution, so it's just 4 squared plus 3 squared, which is 25. So the radius is the square root of that. I've written it as 5 squared, but probably write that as 25. If it gives you the diameter of the circle, where you got P and Q, and then the equation of the circle, that's actually quite similar to this, but the first thing you've got to do is work out the centre. So the centre of a circle is the midpoint of the diameter. Work that out first, so halfway between 5 and -2, and halfway between 6 and 2. Find the midpoint and then do exactly the same as this question. Substitute in the centre and one of these points, doesn't matter which one, because they'll both give you the radius of 65 over 4, square root of 65 over 4. But just keep it like this. There's no point square rooting it and then squaring it again. Next, it's expanded form. So this is in the expanded form. It wants you to write it in the factorized form. So you complete the square twice, once for x and once for y. So complete the square on x squared minus 10x, which is x minus 5 all squared. Take away 25. Do the same thing for the y's. So y squared and 4y becomes y plus 2 all squared minus 4. And then there's, don't forget that minus 20, which was there to begin with and still there. Combine all the constants together and put them on the other side of the equation. Once you've got it like that, you can get to the centre and radius by just doing what we were doing before. Centre is opposite signs and the radius is the square root of that. All of these are just practice doing the same thing, apart from E is a bit different. So with E it says 2x squared and 2y squared. The best thing to do, as long as those are the same number, is a circle. I would just divide everything by 2. Before I did that, I combined all the like terms. So I brought the 2x, take away 2x, so it's take away 8x, and then add 3y, so I've got plus 8y. And then halve everything. Remember to halve the constant as well. Once it's like this, then it's the same as the other ones. You complete the square on the x's, complete the square on the y's, to combine all the constants, get the centre and the radius. Okay, but just as long as this is the same coefficient as that one, you can just divide by it. If they're not the same coefficient, it's not a circle, so it doesn't matter. It'll be an oval shape. If you're trying to find where something meets the x-axis, you're making y equal to 0. So in this case, just replace the y with 0, and you get a quadratic. Solve the quadratic. If you're trying to find when something meets the y-axis, you make x equal to 0, and then do the same thing. So you'd have x is 0, so 0 minus 2 squared plus y, blah, blah, blah. You have a quadratic in y, solve the quadratic. Okay, now it gets on to finding where points of intersection are. So you've got a line meeting a circle. Okay, so any time where anything meets anything else, so lines meeting lines or circles meeting circles, quadratics meeting quadratics or whatever, all you do is solve them simultaneously. With circles, you're going to do that by substitution because you can't really easily make like y the subject of this. Or at all. So what you're going to do is put x plus 4 in place of y. So you can see that's what the first thing I've done here is. The only difference between that and this is instead of writing y, I've written x plus 4. Simplify this, so you get x plus 4 minus 5 is x minus 1. And then expand, simplify, simplify a bit more, simplify a bit more, solve it to get your x values. And then just remember to, when you've got the x values, if you're finding coordinates, you need to find also the y values and use the simpler equation. You could put these x values into here and then solve for y, but it's so much easier to put them into this one. And because it's points where they meet, it's true for both of them. That's what it means to solve something simultaneously, to find ones where it's solutions for both equations. So please use the simpler one. X plus 4, x plus 4. So these are your coordinates. There's a few on this one which are, similar. You're finding points where they meet, so I would make y the subject of this and substitute it in for there, so you get y is equal to x minus 10, and then substitute that in here. When it says it doesn't meet the circle, you're showing it, so all you got to do is show that the discriminant is less than 0. Here you're showing again that it's got 1 point, so same idea to start off with, make y the subject or x the subject, it doesn't matter. Maybe here you do x is 11 minus y, substitute that in, expand it, and then that quadratic that you get, you show that you'll have a quadratic in y, show that the discriminant of that quadratic equals 0. That's the proof that it's only 1 point. To find the coordinates at that point, you just solve the equation. It's a quadratic, so solve it. Sorry. I think this is the last of the more simple questions. There's a couple of tricky ones that I want to go through after this. So anytime when you get a point, you want to use it. So this is an x and a y coordinate. The first one, work out the value of a, could not be more simple. You've got x plus y equals a, and you have an x coordinate and a y coordinate. So literally just 3 plus 10 equals a. So a is 13. The second one's a little bit more tricky, but not crazy. You've got an x and a y coordinate. Substitute them in. So put in x is 3 and y is 10. That's what I've done here. And then simplify this. That's 4 squared. Expand that. Is this. And then solve it. Those are your two values of p. Okay, so if you've got a coordinate, use it. As in, like, it's an x and a y, so substitute it in for an x and a y. Now this is the first one, which is, I would probably say, is the more difficult kind. It's not the worst, but it's quite awkward because there's a quadratic and then there's another quadratic with a different variable. So the line with equation y equals kx intersects this. So when you've got an intersection, solve them simultaneously. I'm going to say that so many times in this video. But if you're finding where a line meets a circle, solve them simultaneously. And with circles, you're doing that by substitution. So anywhere where it says y, put kx instead. So there, kx squared, there, kx. This is what I've put in here. That's the only difference between that and this, is I've put in kx where y was. Expand it, and this is where it becomes maybe different to what you might expect. So you want to collect anything which has got an x squared. So we've got x squared there and k squared x squared there. So collect those together and factorize out the x squared. So we've just got 1x squared. So 1x squared and k squared x squared is 1 plus k squared. Lots of x squared. Do the same thing with the x's. So I've got minus 10x there and minus 12kx there. So minus 10 minus 12k is here. And then there's only one constant, 57. Okay, so I've written here, make quadratic looking. That's not really good English, but you want to make it something x squared plus something x plus number. Okay, so then you've got an a, a b, and a c. And at that point, anytime you see this kind of two distinct points, that leads you to b squared minus 4ac is greater than 0. If it says it's a tangent, make it equal to 0. If it says it doesn't touch it, less than 0. Okay, but anytime you see that, you want to be thinking discriminant. So discriminant is greater than 0. B squared, that's this thing squared, minus 4ac. So I'll put those things in here. Expand it, simplify, and then the only thing that I'd point out in this simplification is we're trying to get to that, but we have a negative 84. So when you divide by minus 4, you have to flip the sign over. So anytime you multiply or divide an inequality by a negative number, you want to flip the sign. So here it says greater than, here it says less than. Solving that, so it says determine the range of possible values for k. Solving this is chapter 3. You want to just find the roots, and then because it's less than, you're looking for the bits between those roots. So if you drew a little sketch, it would be, we want the bit that's underneath the graph. So this is 0.7, it's 2.15. We want the bit underneath the graph, so between 0.71, sorry, and 2.15. That's the bit underneath the graph. There's a few more points. So finding the equation to the circle when you've got a point in the circle, we've done that before. Finding the equation of the tangent to the circle. Sometimes you do that by doing the whole b squared minus 4ac is equal to 0 thing. But there are some other ways of doing it which are less complex. So with this one, you have to know the circle theorem that the radius meets the tangent at a right angle. So because we have a point and the center, we can work out the gradient of the radius. Okay, the gradient of the radius, it goes minus 2 to 6, so that's up 8, and then 1 to 3, sorry, 1 to 4 is up 3, so it's 8 over 3. The gradient of the tangent is the negative reciprocal of that. And you've got a point on the tangent. Okay, it says that the tangent to the circle at P, so that point P is on the tangent, and you know the gradient of the tangent, so y equals mx plus c, and find c. I've rearranged that as well by timesing everything by 8 and moving it onto the same side. Either of these is fine for this question. If it says to write it in that form, then obviously write it in that form. P and Q, this is perpendicular bisector question. So perpendicular bisectors, perpendicular means at right angles, so that's the negative reciprocal. Bisector means that it goes through the midpoint. So firstly, find the midpoint halfway between those. Find the gradient of that line, and you want perpendicular to that. So that's why negative reciprocal is the negative reciprocal of minus 2, so a half. The reason we found the midpoint is because to find the equation of a line, you need a point on the line and the gradient of the line. And once you've got that, y equals mx plus c, find c, and you've got your perpendicular bisector. So that's a line, sorry, a point on the line, and that's the gradient of the line perpendicular to this, the line between these 2 points. Show that the perpendicular bisector of PQ passes through the centre. Firstly, you've got to find the centre by completing the square on this. So it's going to be minus 2 in the bracket and then plus 2 in the bracket. So I did do it all here, but you don't actually have to do it all. You just need to know the centre, which is going to be 2 minus 2. And then to show it, all you got to do is show that point is on that line by substituting in y equals minus 2, x equals 2, and then literally put the numbers in and show that the left hand side equals the right hand side. Right, advanced stuff now. There is another way of doing this question geometrically, so like by using geometry, but the more I do this, algebraic method, the more I think it's very methodical and like very learnable, because it starts in the same place as all the other ones to do with when a line and a circle meet, which is solve them simultaneously. And how do you solve them simultaneously when one of them is a circle equation? You substitute. Okay, so we've got a gradient of 2, but we don't know what the y-intercept is. It's got a picture of it here for us, so we're looking for that point and wherever this one meets up here. So these are the 2 points we're looking for, but we know the gradient's 2. So 2x plus c is one of the equations, and then this is the other equation. It was given to us in the question. So that's the circle, that's the line. Solve them simultaneously by substituting the y in for the y. So all I've done is change y to 2x plus c. The only awkward part of this, well, one of the, I'd say 2 awkward parts of this, is expanding this trinomial. So expanding that's fine, x squared plus 10x plus 25. But expanding this trinomial would be multiplying 2x by every term, including itself. So 2x squared, or 2x all squared, 2x times c, 2x times 3. That's the first 3 I've written down. Then times the c by each term, 2cx, c squared, and 3c. And then the number at the end by each term. So 3 times 2x, 3 times c, and 3 times 3, sorry, to make 9. So when you expand a trinomial, you should have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms before you do any simplification. And the simplification is substantial. We have these 3, these 9, and the 80 all to get combined to make, what I'm looking for is 3 things. Something x squared, something x, and something without any x's. So everything with an x squared, combine that together. X squared and 2x all squared is 5x squared. The 5 there is what I've called a. We'll get to that later. You want to combine together anything which combines or contains an x, so these 5 terms, 10x, 6x, and 6x makes 22x. That says 22. And then I've got another 2c and 2cx here, so that's 4c. And factorise it so that the x is outside and you've got just numbers in there. Remember, c is just going to be a number. It's not a variable. X is a variable, c is a number. It's like a constant. And finally, all the numbers, so 25, c squared, 3c, 3c, 9. Remember, c is just a number, so c squared is just a number. All of these are only numbers. There's 6 of them. Combine them all together to make this. C squared plus 6c minus 46. Okay, so that step is long. Remind yourself what the question is. You are finding a tangent to the circle. So the tangent tells you one of 2 things. Either b squared minus 4ac equals 0. That's the one I'm going to use. Or that the radius is perpendicular to the tangent. That's the geometric way of doing it. And if you're interested, then ask me. But I'm going to use this way. B squared minus 4ac equals 0, because that's true for a tangent. We've got a, b, and c here. So a is the number before x squared, b is the number before x, and c is the number on its own. Okay. These are just numbers, because the c is just a number. So if that's equal to 0, b squared, which is 22 plus 4c, all squared, minus 4a is 5, c is all of that, equals 0. Expand that all. Simplify, that says 56. I accidentally copied this down wrong as a minus, so I had the wrong number here. But expand that, expand this. This is minus 20 times by c squared, minus 20 times by 6c, and minus 20 times by minus 46. So that's one comes out to be positive at the end. Simplify all that, and then you can just put this straight into your calculator and you get the values of 27 and negative 13. Now what they are the y-intercepts. So this would be negative 13, and the one all the way up here would be 27. The y-intercepts of these lines. Yeah, so we know the gradients at 2, but they y-intercept at 27, and negative 13. So yeah, it's methodical, and if you remember this, like if you're trying to find when things touch, or even you've got more than one graph, you've got a circle and some lines, you're solving things simultaneously. That's your first step. And if it says tangent, then you're either looking at the radius being perpendicular, or if you ever end up with a quadratic, b squared minus 4ac equals 0. Okay, that comes up so many times in so many different things. Hopefully you're starting to see that. I think there was one more question that I wanted to do from the exam questions. Here it is. There was a weird part to one of these other questions. It starts off quite nice. So finding the coordinates of A, which is the centre, and it's given you P and Q. So you just go midpoint of PQ. Then the next part, find an equation for C. It's the same thing as you've done before. Substitute in the centre and one of these coordinates to find the radius, which is 15. It says find an equation for C, so it's x minus the x coordinate of the centre plus y minus, or squared, sorry, plus y minus the y coordinate of the centre squared equals the radius squared. Then it gets a little bit weird. They're only 2-mark questions, which means there's not a lot of maths involved, but they're a bit weird because it started talking about chords. And with any of these, my preferred way of doing it is to draw a graph. So I've sketched the circle, so I've got P there and Q, and A being the centre at 3 minus 1. I know the radius is 15, so I've put that on there. And then the last thing is it says that the length of the chord is 20 units, and R is the other part of that chord. So I've just looked at my graph and put R somewhere which is a bit more than 15. So if this distance was 15, I've made it a bit longer and then looked at whereabouts that would be. Now it doesn't matter if it's down here or up here, the answer is the same. Okay, so I've just put that on R because it helps me to then do the length of the shortest distance from A to the chord, because I've got a picture of it, and the shortest distance from a point to a line, if you remember, that's when it makes a right angle. So there's the right angle, and it's going to split it in two because this is 15 and this is 15. If I go to the midpoint of PR, that's going to be where the right angle is. So at that point it becomes quite easy because I've got the 15 here, I've got the radius, and I've got 10, which is half of 20 because it splits it in two. And I just use Pythagoras, so 15 squared take 10 squared is going to be this squared. That's the distance from A to the chord squared is 125. So A is, so not A, the length is the square root of 125, which is 5 root 5. And then the last bit, finding the size of the angle ARQ, I thought that was quite a neat question. Neat. Anyway, I drew ARQ. This is the angle we're looking for. I've called it X. Notice that this one here is also X because it's an isosceles triangle, because these two are both radiuses, radii. So that means both of these are the same length. And what I quite liked about this was, I know it's got to have them. I know it's going to have something to do with this triangle, but this length here, if this angle, sorry, is y, y plus these two x's is going to make 180 in that triangle, and y plus these two is going to make a straight line, which is also 180, which means that they're both x as well. I know I put that on there already, but it was maybe not obvious that these angles are going to be equal to these angles, but because y plus 2x is 180 here and here, and these two angles are the same because these two triangles are congruent, that means that I can just work out x by doing inverse sine of 10 over 15. So it's like a one-stepper, but a lot of the work is done on the graph. That was the last one I wanted to go through. There's a few tricky questions in there, as I say. Circles is one of those chapters where there's nothing more difficult that happens in year 13. This is as hard as it gets, so they're quite hard in year 12. But enjoy, and then bring any questions you didn't understand, especially from the exam questions, to our session.